Hello, in this video we will talk about classical linear regression model, or called CLRM, and its assumptions. So when we have estimated a linear regression model, for example y equals beta 1 plus beta 2 times xi, and we will not stop at this point. So if we do not go further, so it's okay. But usually we have to make hypothesis testing of the beta 1 and the beta 2 and actually to estimate the y value. So based on this idea, there are several very important assumptions have to be involved in the linear regression model. So this is called a classical linear regression model. And the first assumption for the classical linear regression model is that the model is linear in the parameters. So here beta 1, beta 2 in the model in type of linear. So which means, for example, if beta 2 is divided by xi, so this beta 2 is not linear. And also if beta 2 is on power of xi, it's also not a linear type. So here beta 2 is linear because beta 2 times xi. So which means 1 unit increase in xi will get beta 2 times beta 2 unit of yi, right? So this is a linear type of the parameter. Although the x type, maybe we can add more variable, for example x squared times beta 3. So x squared is not linear type of x, but beta 3 is also linear. So this is the idea of the linear in parameters. The second assumption is that we assume that the x or independent variables are fixed in repeated sampling. So for example, in example of weekly income is the x and the consumption is y. So for people in a weekly income, there are many people may have the same income at 220, and another group of people at income 140, and their y value is random, but their income independent variables are fixed. We also say x variables is non-statistic, but the y variable is statistic because we have included a random term in the model for the y, right? But not for the x. X is fixed or non-statistic, non-random variable. The assumption 3 is 0 mean values of disturbance ui. So if we go back to the first assumption, y equals beta 1 plus beta 2 times x plus ui, so this is called disturbance. So disturbance means all other factors that are not explicitly included in the model, but we assume this influence the mean value of ui is 0. So this is conditional xiui. So given fixed xi, expectation disturbance or the mean value of the disturbance is 0. If we look back, so for example for income level 140, so this is the regression line, and disturbance is observed between the real value and this regression line. So for example, this point disturbance is positive, but this is negative, right? But the mean value for disturbance at a given xi is 0. So which means this is a symmetrical distribution around this mean value on this regression line. So also say because this xi given xi mu I is 0, so we can subsume that this ui is not systematically affect the mean value of y, because this is not included in the model. So this random term, we assume this random term have 0 effect in average. Assumption 4 is homoscedasticity or equivariance of ui. So this form is variance of ui given xi is sigma square. So for each xi, their disturbance variance is the same. So this is called homoscedasticity. If we look back, so this figure shows the homoscedasticity. So for each different x value, their disturbance is the difference between the opposite and the regression line, right? So their disturbance has same variance, though there's same variance in this figure, but not same variance in this figure. So this has clear larger variance than this one, right? So this is called heteroscedasticity. So why we need this assumption? The homoscedasticity, which means each y value corresponding to the x will be equally reliable, because more larger variance means not so reliable than a small variance state, right? So assumption 5 is no autocorrelation between the disturbance. So autocorrelation means for different xi and xj value given these two variable, given these two fixed values, their corresponding disturbance has no correlation. So if we look at this figure, for example, ui and uj, this has correlation because this is positive. So ui positive, uj also positive. Ui negative, uj also negative. So this is has a positive correlation, but this figure shows a negative correlation because ui and uj has different sign. One is a positive and another is a negative, right? So this is called autocorrelation, and actually this is very close to perfect correlation. And this figure shows they have no correlation because they are also random value. And the number 6 assumption, which is the last important assumption we have in this video, is zero covariance between ui and xi. So which means the xi is a fixed value, but disturbance is the difference between y and y on the regression line and the real observed y value. So these two has zero correlation. So which means x represents the influence of observed value and disturbance ui represents the influence of all omitted values. They have no correlation. So if u and x has correlation, which means we have missed several important variables in the model which should be included in the xi, right, in the independent variable. So in this case, we have to find more interesting variables in the model to make ui and xi has no correlation. So these are very important 6 assumptions in the classical linear regression model. Thanks for watching.